Hello and welcome. So today we are going to do rotational motion, and here are previous year trends. So you can see for about 15 years, sometimes even 3 questions have appeared, right? And at least one is at most of the time. So rotational motion is a very important topic, and this can help you ace in this exam. So welcome back to Stbg Academy. This is Dhirendra Tiwari, colleague of Sandeep sir. And so today we are going to have this fantastic session, and these previous year questions are really important. They shape your performance and they can help you at the last moment because they are providing you necessary background, right? So you need to do relevant questions, especially near the completion of your preparation. So let's move on. Okay, all right. So the first question says that a shell acquires initial velocity 500 meter per second, which is quite a lot, having made 7 turns inside a barrel whose length is equal to 22 meter. So this is really a big rifle, and snipers use this, or perhaps this is a tank. Okay, assume that the shell moves inside the barrel with uniform acceleration, and the angular velocity of its rotation at the moment when the shell escapes the barrel is. Right, so here 2 things are happening. One, the bullet is moving forward, but it is also rotating. So it's turning on its axis, okay? So it is a combined linear motion, which is uniformly accelerated, plus there is an angular velocity that is acquired by the bullet. Now, angular velocity is important because it gives a gyroscopic property. That is, the bullet is going to go to the target precisely. Okay, with this background, let's move on to solve this problem. So, where do we begin? So, we know when the bullet is out of the barrel. So let us make a nice drawing, okay? So every problem starts with a nice drawing. This is the barrel, and here is the complicated system to trigger and now bullet starts from here in this direction, and it comes out here with 500 meter per second. Let us say this is V. Now we are given the length of the barrel, right? And then we have been also given, it makes 7 turns, right? And it comes out with an angular velocity. Now that velocity is being asked. So in this barrel there will be grooves. Okay, so these grooves make it spin. So we need to know what is the omega about this axis. So it is also revolving. Right, so omega is not difficult. Why? Because omega we can say is 7 turns, so 7 times 2 pi radians, because in every turn it does 2 pi radian. And if we know time of flight, so time of flight we need to know. Now we have been given V and L. Imagine V and S, U is 0, right? This is where the bullet begins. And this is uniformly accelerated motion. Now our interest is to get time of flight, which is easy. S equal to half AT square we would use, and T will be time of flight. Right, and S is equal to L. because this is the length of the barrel. But we don't know the acceleration. But we know S and V. So we can use third equation. V square is U square plus 2AS. Right, and we know S, so we know A. So from here we will get A. The acceleration is V square by 2L. And if you plug it in here, so this is our first equation, this is the second equation. So if you plug the second equation into the first equation, what will you get? So you will get L is equal to half A is V square by 2L, right, and then multiplied by time of flight squared. Now from this we can easily obtain what is time of flight. Okay, so let us write the time of flight. Right, 4L square by V square square root. So this we know, and we can write it down here. 2, instead of pi I can write 22 by 7 and then 7, and time of flight is 2L into V. Okay, this is just separate, 2L into V. This is all clear to all of you. Now let us plug in the values of things, and as we know L is 22, so 7, and L is 22, so L and this is gone. And how much does remain? So, okay, so here the answer is here 500. Okay, so 500 radians per second. Okay, so this is the answer. So answer is B. Okay, let's have a look at the next question. A wheel with moment of inertia 2 kg per meter square about its vertical axis rotates with 60 rpm. The torque which can stop the wheel's rotation in 1 minute. Okay, so we have given the moment of inertia and we have given the omega. And what we can do is we can write tau is dl by dt. So initial angular momentum is given and we know what is the final. right? So we can easily write tau dt is dl, right? And if it is a constant torque, then this will be just change in I omega, what is given, divided by the time. So now you have to plug in the values, 2 kg per meter square. This is 60 RPM. So 60 RPM means 60 revolution. So these many radians per minute. So in 1 minute there are 60 seconds. And time is also given in 60 seconds. Okay, so we can clearly see this is 60 gone, and this turns out to be 2 pi by 30, or actually pi by 15 Newton meter, because torque is okay, R cross F, so it should be, negative power should not be there. So answer is A. Okay, let me move to next question. A cylinder of mass m rolls down without slipping a plane that is inclined at theta angle. The coefficient of friction is mu. What is the maximum value of theta for the cylinder to roll without slipping? Now this is a very interesting question, very beautiful question, and this is in all books, NCERT, Verma, and everywhere. And this is a basic question. So how to approach this? First we make a beautiful diagram, and now here is our rolling cylinder. All right, it has some radius, let's say r, and there is a coefficient of friction. Now this thing moves down the hill, and we can take it moves down with the acceleration a. The weight acts downward, and now the normal goes in this direction, then the component of the weight that is driving this downwards is mg sine theta, and since the motion is downwards, the friction will kick in, and friction will act in this direction. We have been given mu as a coefficient, so here we have the friction, and mu is the coefficient. Right, so this is the basic diagram. Now we have to make two conditions with this diagram, because it is translating but also rolling pure, and it is rolling pure, so it will have angular acceleration alpha. Okay, now alpha and a are related because we know theta is L upon r, so we can write r d theta by dt is dl by dt, the relation. From this we get r omega is v, and if we take one more derivative we get r alpha is a. Now in this question we have been asked what should be the minimum angle, maximum angle for the cylinder to roll pure. So the first condition is this, because it is pure rolling, our condition 1. Now what we are going to do is we have to understand linear motion. Now the direction along which the motion happens, we take it positive x. चॉइस ऑफ कोऑर्डिनेट सिस्टम इज पर्सनल। ओके, तो आप किसी भी तरह से कोऑर्डिनेट सिस्टम ले सकते हैं, बट कंसिस्टेंट रहना होगा। मैं एक डायरेक्शन लेता हूं जो कि ऑर्थोगोनल है प्रोपगेशन के, और वो y है। ओके, तो हमारे x में मोशन हो रहा है, सो mg sin थीटा is driving and friction is opposing, right? And this is the unbalanced force equal to m times a, right? So this is our second equation. Now the third equation we have to consider for the rotational motion. You can see this is rotating about this axis O. Okay, सारी फोर्सेस mg नॉर्मल रिएक्शन ये सेंटर से पास हो रहे हैं, इसलिए इनकी वजह से कोई टॉर्क नहीं होगा। टॉर्क किसकी वजह से होगा? फ्रिक्शन की वजह से होगा। सो Fr into the radius of the cylinder times I alpha. Now I for a cylinder is mr square by 2, right? I alpha, right? Alpha we know is A by R from first relation, is A by R. All right. Now our interest is to find friction. तो मैं क्या करूँगा, ये इक्वेशन में थर्ड इक्वेशन को 3 से मल्टीप्लाई कर 2 से मल्टीप्लाई कर दूंगा। मल्टीप्लाई दिस इक्वेशन बाय 2 and then subtract it, so -2 and then add these two. Okay, तो इससे क्या होगा कि देखिए, and then we also divide by r. Okay, so we will get, ये दोनों टर्म कैंसिल हो जाएंगे, ये आ जाएगा m minus ma plus ma, so this goes to 0. So 0 if we add them up is equal to, अब देखिए ये क्या है, mg sin theta minus fr and plus 2fr. Okay, so what do we get? Okay, not plus, here will be minus because we are multiplying with -2 by r. Okay, so this will be this much. So we can write fr is equal to mg sin theta divided by 3, right? अब हमें फ्रिक्शन के बारे में एक चीज़ बहुत इंपॉर्टेंट है जो मालूम है, इट इज़ ऑलवेज लेस देन और इक्वल टू म्यू एन, right? And we can resolve, the weight has one component, mg cos theta. तो जो हमारा n है, देखिए n क्या है, हम n लिख लेते हैं, n है हमारा mg cos theta. Okay, now we can introduce here then what do we get? mg sin theta divided by 3 is less than or equal to mu times mg cos theta, right? Now once you have this, we can write here tan theta is less than or equal to 3 mu, right? Or theta is less than or equal to tan inverse 3 mu, right? So our answer is B. Right, so our answer is B. Okay, very good question. So please read the next question. Okay, a ballet dancer has a moment of inertia 4 kg meter. So this is moment of inertia, and it's a small value 4 kg when her arms reach her body. So ballet dancer is standing like this. Now 60 kg per meter square, kg meter square when she has arms stretched, because moment of inertia gets larger when arms are stretched. Now when two arms are pressed against her body, right, the speed of the dancer is 12. This is rounds per second. When the arms are stretched, the rotation will be what? So these are the options. So this is a very interesting question. The ballet dancer usually they stand on their feet, they learn about 10 years, and imagine they have no external force. So there is no external torque. So when they can do the dance, they don't have any external torque. When there is no external torque, so this question is about conservation of angular momentum. So angular momentum, it is very easy to understand. L is given by I omega, right? So when the arms are low, I goes down, but the angular momentum is conserved if tau external is 0. So this is the case. There is no external torque. Ballet dancer is dancing freely. So what will happen is I1 omega 1 is equal to I2 omega 2. Right? They have said when her arms are pressed against her body, that means we have to take the lower one. I1 is 4. They have given omega 1 12. They have given in rounds per second. Okay. And SI unit, and here it is 16, and they have asked omega 2. So this question is really easy. Omega 2 will be 4 into 12 by 16. So you can see 4 4s are 16, 3s are, so 3 rounds per second. All right. So the important concept is angular momentum conservation. So our answer is C. Okay. Let's move on. Now this is really nice question. Okay. I'm going to clear the board. Okay, this is really a good question. This is about getting over an obstacle. Now, here we have to see, or how to make this thing move up. So we have to consider torque balance. So there is a wheel of radius r with a weight w to be raised over an obstacle of height h by a horizontal force F applied in the figure. The minimum value of F is given by these 4 options. Now let us try to analyze this situation. I'm going to make this diagram again. Suppose this is our H, which is small, and this is our R. Okay, just think about this as a good circle. And what is happening here is basically its radius is center is here, and so this is at a elevated position. Okay, and then we know this height is H. Okay, let's take this angle as theta. Let's first try to analyze the situation. The weight acts from center of mass downwards, so W, and the force is along the axis. Right, and then there will be a normal reaction from this in this direction. There will be a normal reaction. Now, in order to go up this obstacle, to be raised up this obstacle, just you have to have torque balance. Now, where is the torque balance going to happen? It is going to happen at this point, because this is the point, I would say P. P is the point over which this is going to undergo rotation. So this is the axis of rotation at P. So you have to simply take force F times this distance. This is the torque which is climbing up. Let us say this distance is d. We are going to find F into d. And the thing is, the weight is giving counter torque. Okay, it is pulling it down. So we have to multiply weight with the perpendicular distance. We don't know. I'm going to take it big D. So F into small d should be greater than W into big D. This is the condition. Now, how can we find D and D? This is just a geometry problem. So this is the radius R. Now, in the problem, they have written it as small r. Okay, so let's take as given small r is the radius. Right. So how much is D? Is R minus H. Now, this has to be just equal to or greater than W into D. How do we go about D? We know this distance OP is also R, and we know this is R minus H. This D is R minus H. So if we take sine of theta, let us take sine of theta. The sine of theta will be D upon R. Right, so this is known to us. And this is clearly R minus H by R. Right, what we are interested in is big D. Now, big D is basically R cos theta. We know here sin theta is this. So we can easily write how much is cos theta is R under root 1 minus 1 by 1 minus H by R square. Right, cos theta is square root 1 minus sine square. And if we evaluate this, we will reach the answer. So let us take this thing. minus 2hr is 2h by r. Right, so you can clearly see in this we can take the small r square outside and we will get square root. Right, and outside there is r. So you can clearly see d is equal to h into r minus h square root. So therefore f should be greater than w times square root h into r minus h by r minus h. Okay, so our answer is option A. Okay, somehow w is not there, but you can live with it. Okay, let me move to the next question. Okay, a solid cylinder is loaded on a truck in a manner that the axis of the cylinder is parallel to the width of the truck at a distance d from the rear. If the truck moves with a uniform acceleration a, the distance traveled by the truck after which the solid cylinder falls down the rear edge, rolling down off the horizontal bed, there is friction which prevents the cylinder from slipping. So there are several options. So this is really nice question, and let's visualize the geometry. They should have given also the geometry. So you can take, this is the cylinder inside the truck, this is the length of the truck, d. Okay, you can imagine cylinder is like this is the truck. Okay, something like this, and this truck is moving forward with acceleration a. So they have asked this cylinder, which is at a distance d from the edge, how long will it take to fall? Okay, this we need to know, and from that perhaps we need to calculate how much this truck would have moved. Now we will consider, since they say truck is loaded, cylinder is loaded on truck, so initial velocity of truck ut is 0 and it accelerates with this. Now let us draw the free body diagram of this cylinder. So what will happen? There will be a normal reaction, and you see truck moves forward, so this will feel pseudo force. इसको क्या है, सूडो फोर्स लगेगी. आप जब भी कार में बैठते हैं, कार आगे एक्सलरेट करती है, आपको पीछे की तरफ झटका लगता है, राइट? तो देखिए, आप मान लीजिए ट्रक में है और ट्रक उस साइड कर रहा है, तो आप इस तरफ रोल करेंगे. किसकी वजह से? मास ऑफ द बॉडी टाइम्स एक्सेलरेशन ऑफ द फ्रेम. अब इसमें फ्रेम क्या है? हमारा ट्रक फ्रेम है. तो ट्रक क्या करेगा, ट्रक की वजह से सूडो फोर्स आ जाएगी इस पे, और देखिए ये इस डायरेक्शन में मूव कर रहा है, तो हमारा फ्रिक्शन क्या करेगा, रिलेटिव मोशन अपोज करेगा, सो फ्रिक्शन विल वर्क इन दिस डायरेक्शन. नाउ सपोज r is the radius of this cylinder. We need to find, जब यहां से यहां तक जस्ट रोल करने वाला है, इतने समय में ये ट्रक कितना आगे चला गया, राइट. इफ वी नो टाइम टू रोल डाउन इट विल वर्क. ओके, तो हम सपोज करते हैं ये प्योर रोल कर रहा है क्योंकि उन्होंने दिया है फ्रिक्शन on the bed prevents slipping of the cylinder. So this is pure rolling problem. अब देखिए इसका लीनियर एनालिसिस करते हैं. So driver is MA, friction is opposing, and this is causing M times acceleration big A. Suppose ये इस डायरेक्शन में big A से जा रहा है, right? Some linear acceleration. This is our first equation. The second equation is फॉलोइंग, क्योंकि इसमें ये भी हो रहा है प्योर रोलिंग हो रही है, तो अगर बिग ए एक्सीलरेशन है तो अल्फा क्या होगा, अल्फा टाइम्स आर विल बी बिग ए. दिस इज कंडीशन ऑफ प्योर रोलिंग. राइट, सो दिस इज ऑलवेज ट्रू. सो नेक्स्ट इक्वेशन हम बनाएंगे इसके रोटेशनल मोशन पे. तो रोटेशन कैसे हो रहा होगा, देखिए ये अपने सेंटर के अबाउट रोटेट कर रहा है. अब सूडो फोर्स सेंटर पे लग रही है, नॉर्मल रिएक्शन भी सेंटर से जा रहा है, सो दे कैंट अप्लाई एनी टॉर्क, सो ओनली फ्रिक्शन विल अप्लाई टॉर्क. एंड हाउ विल इट डू, एफ आर टाइम्स द रेडियस will give it alpha like this. So alpha is in this direction, it will roll and it will move. And this is the condition for pure rolling. Ye torque is I alpha. Now we know this is a cylinder of mass m, has a radius r, so mr square by 2 I alpha. Okay. Now what I'm going to do is I'm going to use this condition, so I'm going to write instead of alpha a upon r. Right. अब हम क्या करेंगे, ये सेकेंड इक्वेशन को r से डिवाइड कर देंगे, r से डिवाइड, और ये दोनों इक्वेशन को ऐड कर देंगे. तो हमें इससे क्या आ जाएगा, फ्रिक्शन विल बी गॉन, सो वी विल नो m a is equal to m plus m by 2 into a, right? Because r square cancel, and then what we can see, if we add them we get this. इसको अगर हम फर्दर सॉल्व करेंगे तो क्या आएगा, हमारा बिग ए आ जाएगा a 3/2. ओके, थोड़ी सी अलजेब्रा करके. अब हमें a मालूम है, हमें d मालूम है, सो टाइम टू रोल डाउन, तो td इज, हमें डिस्टेंस मालूम है, s इज हाफ at स्क्वायर, राइट. तो हम क्या करेंगे नेक्स्ट, ये यूज करेंगे डिस्टेंस टू रोल डाउन, क्योंकि उसे इस डायरेक्शन में डिस्टेंस रोल डाउन करना था. बिग ए एक्सेलरेशन से इनिशियल जीरो वेलोसिटी थी, तो हाफ at स्क्वायर. इससे हमारा td टाइम टू रोल डाउन आ जाएगा 2d by a स्क्वायर रूट, राइट. अब ये देख लेते हैं हम बिग ए और स्मॉल ए में क्या कन्वर्जन है. तो ये लिख लेंगे हम 2d. नाउ बिग ए इज a into 3/2. Okay, so this is the time to roll down. Now in this time, how much will this move? The truck ST will move half a TD square. Okay, so if we plug in all the values, half a TD ka square, so 3D by A, right? And then this will give us the right answer, 3D by 2. Okay, so this is really beautiful question और इसका आंसर है D. All right, so let's move on. Now we have got warmed up. Quick. Please आप next question देखिए. Okay, now here is another nice question which is easy as well. Two blocks of each mass m are suspended from the end of a rigid massless rod. Okay, the rod is held horizontally at the fulcrum F. What is the magnitude of the initial acceleration of the block closer to F? Now you can see they are, ये क्या है, equal mass के block हैं. हम ये डायग्राम थोड़ा सा प्रोपोर्शनेट बना लेते हैं. This is L 1 2 3 4. Okay, this is the situation. यहाँ पे हमारा फल्क्रम है. Fulcrum is a point where it is held. Now this has weight mg and this length is L and this is 4L and this is down mg. Okay, तो इन्होंने पूछा है what is the magnitude of initial acceleration. देखिए ये क्या करेगा, इस डायरेक्शन में रोटेट करेगा, राइट? ये किस वजह से करेगा? टॉर्क की वजह से. टॉर्क अबाउट दिस पॉइंट. So tau 1 is mg into L, right? Actually ये वेट बहुत करीब है, ये दूर है, तो इसका टॉर्क ज़्यादा होगा. It will go like that, right? So this will go up and it will move with the acceleration a at the initial point. ये a acceleration से just ऊपर जा रहा होगा.